Hello everyone, and welcome to today's webinar, Maximizing Scale-Out Performance and Reliability with an Advanced Network Protocol. My name is Gabrielle Collier, and I will be your host today. I work on the corporate marketing team here at Panasas. I'm pleased to introduce today's speaker, David Phallic. David is Vice President of Product Management and Industry Marketing at Panasas, where he works on product strategy and positioning, as well as defining market requirements for future products. Before we get started, I want to let you know that today's webinar will be available on demand after the live session, accessible through the same link you are using now. Also, we'd love to hear from you, so please send us your questions and use the Ask a Question tab on the top of your screen. We will answer your questions during the Q&A following the webinar. I'm going to wait just about a minute to give those dialing in late a bit more time to join, so I will be back in just a few. For those of you just joining us, welcome to today's session, Maximizing Scale-Out Performance and Reliability with an Advanced Network Protocol, presented by David Phallic. So let's get started. David, why is the right network protocol so important?
Hello, everyone. My name is David Phallic, and I'm here to talk about why the right network protocol is so important. The experience of servicing the file application users in the world today requires them to be able to get more work done connecting to shared access storage in large work groups more than ever before. The requirements for having the ability to get this work done, usually in large work groups in parallel, often sharing access to the same elements of data, whether it is manually driven as applications or as an automated process through a variety of server-based applications. Trying to leverage the best protocol in order to be able to take advantage of the best capabilities happening in hardware today through new emerging flash technologies and other distributed ways to get work done requires the best capabilities over your network topology. And while you can optimize the network topology itself, there are hidden advantages available to you if you leverage the right ways to communicate to your storage platforms at the protocol layer, which is what this presentation will discuss. So I'm going to continue with the presentation by talking about general concepts about protocols for scale-out file. The scope of this presentation is to talk about scale-out file systems because of the requirements for applications that predominantly perform I/O using file-based I/O, either to a local disk inside of the compute platform or over a network topology layer. While there are scale-out systems that cover block and object, this presentation will be discussing unstructured sequential data sets, which are best serviced through scale-out file. These platforms tend to do well by supporting open protocols in order to ensure that the users have the ability to reach their data regardless of the ability to have to use some type of proprietary mechanism to get access to that data. The common methods to do this are using two predominantly available protocols, NFS and SMB. And there are various states of versions with these protocols. Version 3 and version 4 of NFS are commonly available today. And in 2010, a new version subset of NFS was introduced called version 4.1 or PNFS. This stands for Parallel NFS. It added parallelism to the NFS protocol specification from the IETF. However, this specification has only been adopted in specific use cases by the marketplace, which leaves many people wondering what was missing with the possibility of what that could do. In addition, new advantages and capabilities have been deployed through SMB, Server Message Block, provided by Microsoft. Version 2 and version 3 are commonly deployed, but version 3 introduced an idea of multipath. It's a variant of parallelism. It is very specific to Microsoft platforms. And the challenge with SMB is that definition has been difficult to adopt into existing clustered scale-out NAS technologies. So what we're going to talk about in this presentation is how to get the best of these concepts of performance through parallelism, but doing it through a technology method that Panasas has pioneered and founded in its own platform called direct flow. To do this, it's helpful to illustrate the concepts that exist with NAS technologies. This is network attached storage, which is addressed via file protocols. Common things that occur when you address network attached storage over file protocols is that you are using these protocols in order to be able to get somewhat deterministic I/O patterns from your file delivery of metadata and data blocks to a shared access platform, and that those files and blocks that you land on that platform can be read by others in a managed way. So in legacy scale-out NAS, the traditional way that shared access to a common namespace has been provided to users over quite a long time. What this usually requires is an NFS or SMB connection from a client to a server, such as Windows 2008 or 2012 R2, or any variety of Linux-flavored servers or Mac-based servers that will provide an NFS or SMB connection to the client. An ingredient that's involved with this, as client load builds up on the server, is that the file server also manages the metadata layout for how the data is distributed across hard disks in a variety of form factors, whether that is spinning disk or solid-state media such as flash, or some hybrid thereof. And the data is organized and laid out onto these storage objects, and it is done usually by organizing those disks into RAID sets for data protection. The challenges that result from this topology that have been in existence for more than 20 years are that file servers being in the data path, while they do manage all I/O, they also become a bottleneck at scale because I/O can overrun the server since it is effectively a choke point. And while you can virtually scale out these file servers using a variety of technologies available either in Linux platforms on the server basis or Microsoft with DFS, distributed file services, the fundamental underlying challenge still exists in that you're managing multiple file servers as gateways to the data behind them. And these multiple pools of storage that must be managed via these multiple servers presenting that data present bottlenecks. So in the early 21st century, so beginning around the 2005 timeframe, products began to ship in the marketplace that introduced the concept of clustering. Clustered scale-out NAS emerged as an outgrowth of high-performance computing and clustered computing as a way to be able to take clients and connect them to distributed servers that also contain the storage, but distribute all of the data within the storage across the servers in addition to distributing the metadata. And clients connect to each server, and as a server is a storage node, these client connections are very evenly balanced and distributed across all the storage nodes. Data protection has emerged in clustered scale-out NAS as a non-fixed, non-LUN-based concept by leveraging erasure coding concepts, such as Reed-Solomon, in order to be able to distribute the data protection evenly across all of the file servers managing metadata. And the metadata server itself and the layout of metadata is also distributed. There are many advantages to clustered scale-out NAS. Clients are able to have a point-to-point link to one cluster node, but there are multiple clustered nodes to be able to maintain multiple client links. The I/O is distributed across these nodes, and the expansion of the namespace is elastic because there are no LUNs. This concept of scale-out NAS has taken off significantly in the marketplace, coming into, especially since the 2010 timeframe. There are many platforms that offer this concept in the marketplace. However, around this same time, the NFS v4.1 specification was formally brought out to the marketplace, and it introduced the concept of being able to offload or offset metadata transactions by introducing the concept of external file servers that would use PNFS as an example to be able to request how to lay out their data from these namespace servers that contain the metadata layout of all the disks. And then the clients are able to perform a direct layout across multiple nodes of disk, as opposed to laying out the data into one node among many. This introduced the concept of parallel I/O for writes and reads. The powerful thing that occurred from this concept is that the metadata on these namespace servers, while distributed, just like a clustered scale-out NAS, and eliminating the file server bottleneck of traditional file servers presenting a namespace as network-attached storage, you still need to manage multiple pools of storage LUNs underneath. So there was still some complexity to this concept, but it had a lot of broad appeal to the marketplace. However, while PNFS as a concept, or the NFS 4.1 specification, was fundamentally designed to support block, file, and object, there are other platforms specific to block and object that perform these concepts already natively well today, but were challenged to perform it well and get adopted in file. File platforms have not widely adopted 4.1 PNFS at scale in the marketplace. And what have the bottlenecks been? In many cases, it requires a platform to have PNFS designed in fundamentally to the architecture. It's very difficult to add the concept of PNFS to an existing clustered scale-out NAS in the marketplace because the data layout concepts are fundamentally different than the way clustered scale-out NAS has been brought to the marketplace using traditional NFS and SMB protocols. So in the marketplace, there are alternatives, and one I will be describing here is what Panasas can offer through a concept it offers called direct flow. It is our version of PNFS, or NFS 4.1. It's the native experience of PNFS on scale-out NAS, designed into the product. It is a client-side operation for performing data parity calculations, so it advances the PNFS concept beyond the specification into adding advanced features for the client side, including an SDK for modifying file I/O parameters, as opposed to the traditional way that you modify file I/O window sizes through NFS or SMB client-side specifications. Now, an additional thing to keep in mind is there is an alternative on the SMB side that was introduced in version 3 called Multipath. It's one of the many definitions that was introduced within SMB 3, specific to introducing parallelism for the server message block protocol. While this is a file-specific definition of parallelism for SMB, it has not been widely adopted at scale in a manner that drives significant performance at scale across multiple storage components in a scale-out clustered NAS fashion. So bottlenecks include the fact that the platform must be designed with front-end parallelism support, and current modern clustered NAS cannot easily implement the SMB3 multipath protocol in a manner that distributes it across multiple nodes within a cluster. So for Panasas, we are offering through our direct flow, an experience that is similar to what SMB3 Multipath tries to offer in concept, but it is difficult to be able to execute in a clustered scale-out NAS way in the marketplace, including the benefits that were available to those users who were looking for PNFS-like experiences on the NFS library side, such as data parity calculation on the client and not in storage, as well as an SDK to modify significantly wide portions of how you perform I/O as opposed to being able to just change concepts such as the window sizes of the transfers of the data that you send through server message block. So an explanation about direct flow, which is an advanced state of what was introduced originally in 2010 through PNFS and what Microsoft has introduced through the concept of SMB3 Multipath. It's a performance architecture. So the fundamental nature of why direct flow is so that users get the benefit of being able to leverage a performance protocol in order to be able to reduce time to results and take advantage of all storage resources in parallel in a manner similar to what SAN platforms are able to offer through the ability to have a means by which you can address multiple storage components in parallel when writing and subsequently reading data, and being able to do this in a highly available way that results in high bandwidth. So you get better performance than NFS and SMB on file-based clustered scale-out NAS platforms, and you are able to support more clients per storage node as a result of the inherent balance that results from parallelism. There is exceptional aggregate performance, and you can also avoid, through the direct flow approach of parallelism, some bottlenecks that are typical of clustered scale-out NAS file systems. This includes being able to move the parity calculation, a very important part of data integrity inside of scale-out NAS systems, being able to shift that process away from the storage platform and move it to the host. By doing so, lifting that erasure coding burden from storage releases performance and improves I/O dramatically. And while there are a variety of ways in the marketplace that you can advance performance at a blunt level through the utilization of flash and the increased bandwidth available through larger connections in I/O, not just 10 gig, but the emerging adoption of 40 gig Ethernet on the client side as opposed to top of rack, connecting multiple racks of components and switching purposes. Being able to use these higher bandwidth interconnects means parallelism is becoming even more important because the data payloads are even larger. And all of that erasure coding that must be performed on clustered scale-out NAS in order to ensure the data is protected. When the data comes in large amounts, being able to distribute that in a parallelized fashion allows you to extract additional performance from your infrastructure. So let's take a moment and talk about what it means, first of all, to present a file system that is a multi-protocol namespace. A very important criteria when being able to present to users the ability to get both performance and accessibility and availability. For us, direct flow maximizes client performance in the manners I've been describing. It's a parallel direct I/O architecture. It was a framework that contributed to the PNFS standard 4.1 introduced in 2010, where I/O is distributed across multiple storage components, in our case, storage blades, and metadata is managed in a distributed fashion, as a clustered architecture should, through distributed directory blades that scales metadata access for clients. What it means is being able to take advantage of factors such as calculating data parity on client as opposed to on storage, and being able to live alongside NFS and SMB for purposes of performing I/O, but with parallel I/O, being able to address metadata servers, part of the PNFS specification, to get your data layout. And then, much like what PNFS and SMB3 Multipath are intended to do, be able to address all the storage resources in parallel through the right process over 1 gig or 10 gig Ethernet, and do this at scale across multiple clients. allows you to be able to address the entire namespace of all the clustered node components from a single client and do this across multiple clients at scale. What this ultimately means is there are different ways to approach clustered scale-out NAS for your file I/O workload requirements that need performance. Current scale-out NAS platforms available in the marketplace will manage client I/O in a very balanced fashion up to a point. They support NFS and SMB connections. Clients connect per node. And what you're going to find at a certain point is as the I/O occurs, the data parity gets calculated on storage because true clustered scale-out NAS is elastic and takes advantage of having a distributed data layout process through erasure coding in order to be able to avoid managing the complexity of hard LUNs on your storage side platform. However, that flexibility does come at a performance cost. The calculation of data parity on storage introduces overhead, which will reduce performance. In addition, the native state of NFS and SMB protocols is such that they are unable to address the entire namespace in parallel from a write or read perspective. They can virtually address the entire namespace from a mount perspective, but not from an actual write or read. What can happen as a result of this is you can overburden or overload one node of a storage cluster through excessive amount of I/O on that node within the cluster. What happens from this is the point-to-point connection, which is an inherent aspect of the relationship of NFS and SMB versions 1 and 2, results in I/O hotspots due to uneven distribution of clients and the additional overhead of data parity calculated on storage. You'll note that I have not mentioned SMB3 Multipath. While it would be ideal for an SMB3 Multipath client to be able to address 3 or more storage nodes within a storage cluster and scale out, unless it's actually inherently designed within the cluster platform itself, this is not possible to do at this time, meaning that SMB3 Multipath is still a point-to-point connection between the client performing that type of I/O to one node of a storage cluster. The true way to look at how to be able to get performance from scale-out NAS is to recognize where the bottlenecks are. One bottleneck is erasure coding and storage parity. If that process were relieved as a burden from storage and performed on the client side, because clients these days have significant amounts of compute capability within them, and being able to perform that task, especially leveraging x86 and certain erasure coding calls that can be done within the x86 processor itself. Leveraging that processing power within the host as opposed to performing it on the client releases additional performance because that burden is now shifted away from storage to the client. And the client has plenty of ability to perform this with very low overhead, usually less than 1%. And the client subsequently then is able to address multiple storage nodes in parallel when performing that write. This scales and becomes our direct flow protocol with multiple clients addressing all the nodes all the time in parallel. Additional advantages occur. Each client has a one-to-all connection to all nodes within a clustered scale-out NAS of Panasas. All client load is automatically auto-balanced with a wide front-end Ethernet profile. This results in no storage hotspots because all nodes are addressed from a single client. In addition, one factor that is a resonant impact area within this illustration is that should one storage node become unavailable, it is now commonly available within the NFS3 specification and the SMB3 specification that those client connections can be rebalanced to adjacent nodes, but that creates a pause in I/O while that client is reconnected virtually from the impacted node to an adjacent node in a cluster. When you address all nodes in a scale-out NAS through parallelism and through our direct flow, the outage of one node within the cluster does not cause a reconnection event to occur. All the additional nodes are still available for I/O, and the clients continue to perform writes and reads without an interruption to their stated connection, because they are addressing all nodes at once, not just one. A consideration about direct flow is this protocol is available on our ActiveStore platform. This architecture overview gives you an insight into how direct flow works on our platform in a very simplified fashion. We currently distribute today direct flow, historically, using Linux. And we have RPMs available for all the various flavors of Linux available in the marketplace today. In addition, the platform of Panasas called ActiveStore supports open protocols, NFS and SMB, with all the benefits and limitations that have been explained in this presentation so far. But it is a cache-coherent availability of those two protocols, NFS and SMB, alongside direct flow, such that the use of any one of these protocols by a client to connect into our file system, for example, with a Windows workstation over SMB or a Mac workstation over NFS, into our platform of ActiveStore, is able to get a cache-coherent benefit from any clients that are writing into our platform or reading to it using our direct flow for Linux. And with our ActiveStore platform, it is a true clustered scale-out NAS platform that offers high parallel performance. The pedigree of this platform has been in HPC, high-performance computing, where there is a significant amount of performance, especially oriented around high throughput, extreme throughput, that must be supported. And historically, this platform has accomplished that in the marketplace very well, with direct data access and SAN performance at Ethernet scale. It is a flash-optimized scale-out platform as well. The thing to realize about ActiveStore is that as a true scale-out NAS platform, when you add more units of ActiveStore, you get a true clustered scale-out NAS experience that is very easy to deploy and very easy to manage. You'll notice in the explanation that I've offered so far, direct flow is a Linux-based protocol and historically has been for over 10 years. For the first time, Panasas is bringing this protocol to other platforms. The first platform we're bringing it to is the Mac platform. It is the Linux benefits of our parallel I/O platform of direct flow brought to the ecosystem of Apple, where the workloads, including media and entertainment, academic and university environments, are able to take advantage of the high performance benefits of our direct flow protocol on the Linux platform. We have previewed this technology at major trade shows, including the NAB show in Las Vegas in April, and we have it available for additional preview at our website. You can see the YouTube link we have available on our screen, but you can also go and take a look at this at panasas.com/directflow4Mac. At this time, I'm available to be able to answer questions that may have emerged from this presentation of how to unleash scale-out performance and reliability by maximizing that performance through the direct flow protocol. Gabriel?
Thank you, David. And we are going to start the Q&A in a minute. We have been getting questions, but I would encourage you to add all your questions to the question panel. If we do not get to all of them, we will definitely be sure to reach out to you after the webinar and send out the answers from David. So, David, the first question I have here, is the market responding well to direct flow?
Historically, direct flow has done very well in the marketplace by being able to take advantage of its embedded capabilities of both parallelism and the erasure coding concept, and removing that from storage to the client side. And this has been adopted well within the manufacturing marketplace, the university and research marketplace, the life sciences marketplace in particular has seen very significant adoption recently with the direct flow protocol. And the media and entertainment marketplace is particularly excited about the introduction of the direct flow protocol for Mac, so that the benefits of high performance, typically found in SAN architectures, can now be added to NAS architectures for the first time coupled with the ease of use and ease of scale of true clustered scale-out NAS. So the market so far has been incredibly interested, especially in the media and entertainment space, around the introduction of the DirectFlow for Mac platform, and the ability to introduce that parallelism along with ease of use and ease of scale to a marketplace that is incredibly hungry for performance, coupled with a platform that has always been known worldwide as a leader in creative expression in the marketplace. So we have seen significant interest, which is what's caused us to create the DirectFlow protocol on Mac for the first time after being on a decade on Linux.
That's good to know, David. Here's another one. What will you do next with DirectFlow?
One of the things that's clearly emerged with the fact that Panasas has offered DirectFlow as an advanced version of the PNFS specification available in the marketplace is that customers are, while very excited about the DirectFlow for Mac, are asking, that clearly means you're on Linux, you're about to be on Mac, what is your Windows story for DirectFlow? And we are very excited to be able to share that we are exploring ways to deliver the DirectFlow experience to the Windows platform, and there are a variety of architectural considerations of how to do this. We are taking advantage of the fact that Microsoft has introduced a lot of concepts of parallelism through the SMB3 Multipath protocol specification, and the challenges that exist with being able to deploy it and take advantage of it have meant that it has been limited in its use cases to very isolated instances. And the opportunity we would like to share with the marketplace is that if we can take DirectFlow and its benefits previously experienced on Linux and about to be experienced on the Mac and share that with the Windows ecosystem, then all file performance users of applications that require high performance I/O can choose the platform of their choice and get the DirectFlow experience regardless of the platform they use. So this is something that we're currently exploring from an architecture perspective, and we are consulting with many of our customers and some interesting prospects that have come up and asked us to take particular care about how we bring DirectFlow to the marketplace in an expanded fashion in order to try to drive better adoption of parallelism in the marketplace compared to the ways that have been attempted in the market so far.
Great. The next question here is, will you open up DirectFlow for Mac or DirectFlow to the market?
So this is an interesting question that comes up quite frequently because Panasas has played a role in the PNFS specification. Our participation in that specification began in the 2007 timeframe, and there is quite a lot of material out on the internet that if you look into PNFS, you'll find specifications for how it is deployed within the Red Hat platform of Linux, as well as within certain manufacturers. Examples include NetApp and other vendors of scale-up and scale-out NAS platforms. What you'll find historically is that in that marketplace, when the open sourcing of that specification occurred, a lot of things that were intended benefits from our point of view were not able to be achieved within the specification. So it leaves us at this interesting crossroads that what we could do in the marketplace is improve the benefits as experienced through parallelism of PNFS. But the best way for Panasas to do that at present is by being able to bring a broader ecosystem of DirectFlow as an experience to the market first. And then the ways that we're evaluating how to determine where to go next are quite open. And we are actively seeking input from the marketplace. And in fact, we have some very exciting news that we'll be announcing at some point in the near future about how we are really taking the open source marketplace into consideration with a new look, a fresher perspective. We have our historical pedigree that says we have already contributed a lot of intellectual knowledge about how to do parallelism, and that is what the PNFS specification contains. Our thoughts around how to get parallelism and improve the ability for multiple clients working in clustered fashion with storage and leverage those benefits at scale. We've offered a lot of points of view in that historically already. And that has come from our chief scientist, Garth Gibson, along with others who have worked with Panasas historically over the years. The next challenge and opportunity for Panasas is to determine how to take the more advanced state of parallelism, which DirectFlow offers, and share that to a broader, larger marketplace. Our current initial goal is to be able to deliver that as a platform experience optimized with our ActiveStore platform first. Where we take it from there is open to much debate, and we look forward to that discussion.
Awesome. So I wanted to close out the question and answer session here, but do feel free to reach out with your feedback, inputs, or questions around DirectFlow or even in general about Panasas, and we can be reached on our website, www.panasas.com. I have also attached a link to access DirectFlow for Mac webpage, which has a video, which is the demo of the DirectFlow for Mac that we did in NAB this year. And with that, I wanted to thank you for joining us today. Thank you, David, for presenting. And please feel free to reach back with any questions or comments. Thank you and goodbye.